So that's the NPN. And it would be the same for a PNP. So in the case of a PNP, if the transistor is good, okay, you will measure 0.7 between the emitter and the base. Between the emitter and the base, you have a PN junction, so about 0.7. Between the collector and the base, you have another PN junction, 0.7. But between the collector and the emitter, you will read no voltage. So that's one way of testing a transistor. With new multimeters, such as the kind that you may have, some new multimeters have a transistor testing point, and they are holes like this, and it says PN, PN, okay? And so what you will do is you will take your transistor, and if it's an NPN, you will put it in those last three holes, and you will get a reading on the transistor if it's good or not. If it's a PNP, you would use the first three holes. So that's you have one? Yeah, in some people, with some meters, it is a horizontal thing. In other cases, it will be like this. Okay, once again, it may indicate on it the NPN or the PNP, and then you insert in your transistor just to do a quick check to see if the transistor is good or not. So that's what you do. Okay, so you can either test it using a multimeter and measure the voltage, or you can do it using these built-in features. Okay, so now that brings us to the fact that we have this transistor, and it is a current-controlled device. Note 2 says the bipolar junction transistor is a current-controlled device. So, what currents are we talking about? We have 3 leads, so we've got 3 currents. The current in the collector, the current in the emitter, and the current in the base. Okay? Now, look at the direction of the currents. We've got N, P, N, and we know that if you want the PN junction to be forward biased, then you've got current flowing in a PN junction this way, from the P side to the N side. So that means that the current in the base would be flowing this way, and the current in the emitter is flowing this way. So that's why we show in the NPN the base current flowing into the base. On the emitter side, it's coming out of the transistor. Okay, and the collector is the sum of base and emitter. Okay, so that's the NPN. In the case of the PNP, P and P, once again, current will flow in the diode when it's forward biased this way. And so the arrow is pointing to the direction of the current flow as well as your PN junction. So emitter current flows this way, base current flows this way, and collector current flows up. So what happens with these transistors is the NPN and the PNP are like mirror images of each other. Okay? So in the first case, the voltage and current is, in the 2 cases, the voltages and currents are opposite in polarity. So, the BJT transistor is a current control device. The amount of current in the collector is controlled by the amount of current in the base. What that's saying is that this current in the collector is going to be based on the current in the base. Typically, IB is very small, the current in the base is very small compared to the current in the collector and the emitter. So, what I want you to do is draw in this space you have here a little picture. So everybody get a pencil out, and on page 4, you've got some space at the top. I want you to draw this picture. Page 4. Draw this. What does it look like? A faucet. So the way the transistor behaves is like a faucet. So everybody try to draw a faucet the best you can. Doesn't have to be perfect as long as right here. Draw something that looks like a faucet. In fact, let's write faucet here. Okay, so we've got the tap at the top, that's the base. We've got liquid that's flowing, that's the collector. Liquid coming out, emitter. This helps us understand how transistors behave, how transistors function.